Hello, everyone. My name is Michielli. I'm the Senior Director for Data and Weather Technology at AccuWeather, and I'm accompanied by Tim Loftus, who's one of our data scientists on the team. We're here to talk to you guys about how weather matters to your business and how it can impact your bottom line. So you may be familiar with AccuWeather through using our mobile app or checking out our website, or seeing it through some of the more traditional media like TV, newspaper, that sort of thing. But we're excited to announce that same data that you know and you're comfortable with is now available through Databricks Data Marketplace. For more than 60 years, AccuWeather has been helping people to understand how weather impacts their business, their lives, to help them remain safe during difficult situations, help them to understand how weather can improve their bottom line. And one of the things that we're going to do here today is walk you through a couple of examples of how weather data that's now available in Marketplace can help you drive better business decisions. I'm going to pass it over to Tim to kind of introduce our demos.
Yes, weather can shut down facilities, it can reduce or promote demand, it could also influence and disrupt supply chains. And every sector of the economy, weather in some way, in some measurable way, can influence it and impact it. At AccuWeather, we find many of our customers use weather information in different ways, and our hope today through this lightning talk is for you all to be inspired about how you can use and innovate with your own business applications using our weather data, available in the data marketplace now. So if you're a retailer, for example, wanting to predict store sales or in-customer traffic, or you're in healthcare and you're wanting to predict asthma-related hospitalizations, you can use weather information and predictive analysis to do that. So our first demo that I'm going to show you guys all today is a demo surrounded and based on predictive analysis. So this is a notebook that's also available. You can view it and get a preview of it and kind of mess around with it. It's a template. It can serve, again, as an inspiration for you to use and input your own data. This notebook uses data from a publicly available data set through Calgary in Canada. It has historical solar generation data from several different solar PV sites. A part of any analysis, the first step is data engineering. So what we're going to do is we're going to query some of that information through these next commands, get an understanding of where these sites are located. It's all daily historical information with solar capacity as our target variable. We're going to take a look once we plot this and join this to our delta table from historical daily information at Beer Spa facility, and we're going to take a look and visualize that information here through several different time series plots. You can see the solar capacity, that top plot. There's some seasonality to it, so there's some sort of weather influence to this demand data. You can see how that compares to the seasonality among other metrics that we have available, like cloud cover, humidity relative or relative humidity, solar irradiance or solar radiation net, temperature real feel, a proprietary AccuWeather parameter. Once we have this data frame available for us and ready to use, we can throw that into a correlation analysis, kind of understand what's the influence, what's the significance of different weather parameters in our delta tables as it relates to solar capacity. The brighter the blue, the more influential. So you can see in this plot here, solar irradiance, solar radiation net. We're looking at solar data, so it makes sense. But real feel, temperature, min and max, wind speed, not so much. A lot of this information has some multicollinearity issues. So when we go through this analysis, we want to detect which ones we should drop. And we do that through this workbook here. We can identify 5 key significant parameters: degree days cooling, cloud cover, precipitation, solar radiation net, and wind speed. all being a major factor in demand of solar at these facilities. Once we have that training set ready to go, we want to be able to validate that. So we've targeted one site that we are going to use as our validation set. That's where it's located in Calgary. We're going to do the same process, joining the data to our AccuWeather weather information, and now we can begin modeling. So in this example, we're using a gradient boosting regressor. The fun thing about this, as a data scientist or an analyst, you can plug and play any type of machine learning model that you want. Again, this is just a template for you to get inspired and apply it to your own needs. But for this purpose, or for our demonstration, this model we applied, we're running some statistics. You can see that it's decent, an R squared of 84.7. Probably could get more and more improved. We're only looking at weather though, so if you want to incorporate maybe site characteristics or other information that can influence the demand.
Like elevation or the duration of the day, kind of. Yep.
Exactly. So, or maybe coastline distance, yep. Something like that. You can apply more environmental parameters to this model. From there, we want to be able to visualize the feature importance. So here we can see clearly that solar radiation net is the predominant parameter in this model. Once we have that kind of understood, we want to be able to validate this against that Hillhurst station. So our actual predictions on the left versus the predicted values on the right. Again, not perfect, but pretty decent. With that validation set, 69%. So that means 69% of the variation in this sample data set is explained by AccuWeather parameters alone. So a pretty interesting analysis and finding. And you can see comparative to what was actually occurred and versus what's predicted. The orange line is our model output. A pretty decent model here that's kind of showing when the increase in demand in solar capacity occurs and when we don't see that so much. So again, this is just one example or pattern of use. There's several others. Another one that we find within AccuWeather is related to weather targeting. So a good example of this is Starbucks. Previously, they worked with AccuWeather using weather information to target and strategize around when they should launch their pumpkin spice lattes campaign. So when people switch from hot to cold or cold to hot, you can use this type of method, this pattern of use, within your own business applications to get ahead of when people are going to be more interested in consuming a certain product. For this demonstration, we're going to use some sample data provided from the US Department of Agriculture, exploring the different product categories. So again, we're querying the sales data. It's at a weekly level. So we from the weather side, we'll have to aggregate our data, our daily data, into weekly bins, and then merge that and join that to the sales data and begin to explore it. So we do some visualizations in this demo notebook, plotting things like what is the predominant product categories in the United States for the states that have available data. We find that beverages and meats, eggs and nuts are the two top product categories that people are consuming here in the United States. So how does that relate to weather? You can see that with these two plots, there is a seasonality component to it. So we know that weather should be used in this type of analysis. There's clear indications of a diurnal cycle there and an annual cycle. So moving along in this demo notebook, we're going to again do some more visualizations and plots, kind of get a lay of the land of where we see the predominant sales occur for beverages. And now we're going to start incorporating weather information into this analysis. So for this purpose, we're going to do a trigger using a logistic regression, so a binary. Is it going to increase or is it not? And we're going to do a week over week lag difference and then create a bit. When we see a change in weekly sales, we're going to make as a 1. When we don't, it's a 0. And we're going to use weather to kind of visualize and model when we should trigger a beverage campaign. And it varies across your geographic area. So this is state information. You can see that depending on where you are in the country, it could change. So this triggering pattern of use is really a spatial analysis trying to target when and where we should launch or focus our efforts, advertise beverages, and it's not all at the same time and it's not all related to the same weather. So we're going to merge and join that information with our AccuWeather data again, do some correlation testing, kind of understand which parameters are going to be most influential to that percentage increase in sales. Again, it's a pretty in-depth analysis, but for the sake of time, we're just going to jump right to the output and kind of show you how that visualization of this model and this logistic regression works. And it's using, again, ML to do it. So as time goes on, you can see which states in blue are going to be triggered. And if you're a beverage sales company and you're wanting to get ahead of launching your next marketing campaign, you can use this and weather information to do it. And the last one that I'll highlight is around exploration of our data. So it's not yet on the marketplace, but it will be soon. We have AccuWeather climate normals. Right now we have 10-year and 20-year climate normals processed. We'll have 30 years loaded and processed coming in future versions. But climate information is super important too for industries like manufacturing facilities that are wanting to understand risk. How is our forecast for the next week related to the last 20-year period? Is it going to be more abnormal or less abnormal? So this notebook kind of walks you through. It's more of a beginner level exploratory analysis. We're going to just query our climate normals data set, select 11 locations, keep postal codes, and be able to kind of plot and compare the difference between an 11 or a 10-year normal and a 20-year normal. And you can see that depending on the location, you'll have an average that's different for various parameters like cloud cover and precipitation. And we can kind of compare that with a 20-year normal. And it's difficult to see here, but there are slight differences in both temperature, precipitation, all across the country. We can see that more visibly here through this plot. I selected data out of San Francisco. It is roughly 4,265th hour of the year, if you were curious about that. So let's jump or try to find that it's cold here. It's not as warm as it should be. We're looking at temperatures, 10, 15 degrees below normal. And the cool thing about this plot is you can see how weather has changed over the last 10 years. The blue is above the orange, which means that we're seeing slight warming trends in the last 10 most recent years compared to the 20-year period. It's not occurring everywhere, but for a large portion of our data sets, 90,000 locations globally, we're finding this in our climate normals data set. So moving along further down here, we want to group by day and kind of visualize the differences a little bit further by location. You can see here, depending again across where you are in the country, how a 10-year and a 20-year difference occurs. We can tab over to precipitation and wind speed. And using this information kind of extracts insights that we didn't really see before. Things like Chicago with wind, known as the Windy City. Well, it's not getting any windier with climate change. It's kind of staying the same, which is a pretty interesting insight. But for places like LA, temperature is definitely increasing and getting warmer here. And it's also getting significantly less wet. So that makes sense if you are from California, you're more experienced to drought and warming temperatures. We want to rank these departures by location in this next step of this analysis. Databricks makes it really easy to visualize all of this information. You can see LA ranks top among our 11 selected cities as the most warming trended city, but it ranks towards the bottom in terms of precipitation. Again, all of this insight that you're extracting using our weather information is valuable as it relates to your business. So the really awesome power of this software is being able to share this information through the Delta Share and the data marketplace, be able to take this Delta table information and bring it into your BI tools, whether it's Power BI or Tableau. And so what I want to do in the next tab here is show how you can embed our AccuWeather data tables as Delta shares within a Power BI dashboard. Using that same selected 11 cities, you can bring that information and then compare against our forecasted tables how it relates to normal. So if I select one of these locations, say I'm a facility in Brownsville, Texas, and I'm working at the facility, I'm a facility manager. From this situational awareness dashboard, I can extract that this week we could probably see some abnormal increases in precipitation that we're not prepared for. Let me track our assets, make decisions based on weather information and providing you that situational awareness that you didn't incorporate before into your business operations. So again, this is all available now on our data marketplace. I'm going to pass it back over to Eric to show you what's available.
Yeah, thanks, Tim. So this is just a snippet of what we have available today through our data marketplace. There's several different ways that you can get access to this data via our global coverage, right? So we have data by city, by postal code, latitude, longitude queries. We can even do custom location integrations for either your storefronts or your manufacturing plants, wherever your data may be. We have our historical weather data there. We have more than 20 years worth of data in the marketplace today, which includes more than 160 daily parameters and more than 70 hourly parameters. And like Tim talked about, our 10 and 20-year normals. We also have our forecast data, which goes out to 90 days of daily forecast data, which includes more than 90 parameters on the daily side and more than 50 on the hourly side, in addition to roughly 50 daily weather-based indices, AccuWeather proprietary indices that can help you understand further how weather impacts very specific pieces of information. And we also offer our data in prepackaged plans. So we have data in a basic, a plus, and advanced plan. That allows you to kind of explore data at different levels and different price points to kind of meet your business needs without having to try to surf through everything and all these parameters that we have available today. So, as Tim said, this is all available in Marketplace today. The demos that we talked about are available on Marketplace today. So thanks for joining us.
Thank you.